Do I look half dead? No? I look okay? So unlike when we just talk about demand and supply, where we only have one good at a time, here we're looking at bundles of goods. And to keep things simple, we assume just two goods. So every time we draw a demand and supply graph, that's just for that product on its own. But in consumer theory, we look at an entire bundle that the consumer is buying, at least two goods, that to keep it two-dimensional. So a consumer buys two goods, good X and good Y. Both are in terms of quantity. How much X are you buying and how much Y are you buying? So looking at different bundles that a consumer can afford, and so therefore we're looking at two different goods. That's to keep it two-dimensional. You can do it for three goods, it'll be a 3D graph, four goods, whatever, but two goods simply keeps it nice and two-dimensional for us. We have a given income. Let's say a consumer has $100 of income. The price of good X, let's say, is $10. The price of good Y, let's say, is $5. If I spend my entire income buying good X, how much good X could I buy? $100 divided by 10, which gives me 10. How did I get that number? Income divided by the price of X, 100 divided by 10. If I spend my entire income buying good Y, that's $100 divided by 5, so I could buy 20 units of good Y. Income divided by the price of good Y. I can spend all my income buying good X, or I can spend all my income buying good Y, or I can buy combinations of both. This is what you call your budget line. The budget line shows what you are able to afford with your given income. Yeah? As you go away from the origin, what happens to your utility? As you go away from the origin, your utility will increase. So you can see from a constraint point of view, the consumer would like to go as far away from the origin as possible, but what's constraining them is their budget line. Anything inside the budget is affordable, anything on the budget is affordable, anything outside is currently unaffordable. Now, in this topic, we assume that there's no saving, so the consumer will want to be on their budget. So just make a note, we assume the consumer is not saving, so the consumer will be on their budget line. So every point on the budget line would cost how many dollars? Every point on the budget line would cost $100. Okay? That's from the constraint point of view. The budget line is the consumer's constraint. Now we need to look at the consumer's choices. Two goods, good X, and good y. Let's look at a consumer's choices. We said that the further you go away from the origin, utility will go upwards. New definition, an indifference curve. An indifference curve shows points of equal utility. All points on an indifference curve, A, B, whatever these bundles are, all of these bundles give the consumer the same level of satisfaction. We will all have different indifference curves because all of our preferences will be different. So everybody has differently shaped indifference curves. We call this shape convex. It starts out quite steep. This section is quite steep. And it ends up quite flat. And there is a reason for that. Let's say X represents burgers and Y represents slices of pizza. So the two products are burgers and slices of pizza. At point A, what does the consumer have a lot of? Lots of slices of pizza, right? They have so many slices of pizza that another slice of pizza is going to be quite boring now. They already have so much to begin with. They would have been equally happy if they were to give up quite a few of those slices of pizza for one extra burger. Because we hardly have any burgers at point A to begin with, right? We have so many pizzas already that we are quite happy. You can label this arrow the long one. Quite happy to sacrifice lots of pizzas for one extra burger. On the other hand, at point E, what do we have a lot of? We already have quite a few burgers. We have so many burgers to begin with that another burger is not going to be that exciting. So we are quite happy to sacrifice quite a few burgers for one extra slice of pizza. So that explains why the indifference curve is steep on that side and flat on the other side. So as you go from left to right, the slope of the indifference curve in absolute value terms goes down as you go from left to right. It starts off quite steep and ends up quite flat. Is that okay? It's all connected to the law of diminishing marginal utility. When you already have so many of one thing, if I kept drinking this, taking sips of water all the time, first one is quite exciting. Second one, not so exciting as the first. Yeah? You get the idea. So that's the whole idea behind it. If you want to make a note, you can say that the convex shape is connected to the law of diminishing marginal utility. When you have lots of something, you're quite happy to give up lots of that for something else. So that explains the shape. It's convex. Just terminology, don't need to get scared. The slope of an indifference curve is called, this is just the name, is called the marginal rate of substitution, or MRS for short. The marginal rate of substitution. Which reminds me, if you forgot to mention, that the slope of an indifference curve is called the slope of a budget line, the slope of a budget line is px over py. That's also in absolute value terms, px over py. How much is px? 10. How much is py? 5. The slope equals, in absolute value terms, 2. Back to the indifference curve. So what can we say about every point on the indifference curve? It has the same utility. Which one would I prefer? A, B, C, D, or E? Which one would I prefer? A, B, C, D, or E? They are all the same, because they are all on the same indifference curve. It wouldn't make a difference to me. That's just one indifference curve, though. We have several indifference curves. Now be careful. They should not touch each other. They should not intersect. Indifference curves do not touch each other. They do not intersect. They also should not curl upwards. They should not curl upwards. Don't draw this. This is what I mean you shouldn't draw. Don't get overexcited in the exam and do this. That's not right. This is not correct. The reason that's not correct is because you're saying that bundle E and bundle F are on the same indifference curve, which is impossible. Can you see why it's impossible for F to be as equally satisfying as E? Why is it impossible for F to be as equally satisfying as E? Because F actually has more burgers and more pizzas. It actually has more of both goods. So how can F be equally satisfying as E when it actually has more of both? You give up one for the other, right? So it's impossible for it to curl upwards. So don't curl it upwards there. Don't curl it upwards there either. That is also wrong. Yeah, so be very careful. We will check that they don't curl back up on either end. They're fully downward sloping. We call the shape convex. As a consumer, you would like to go as far away as possible. Is that okay? Okay. So now we bring these two together. That's my budget. I would like to go as far away as possible. And now we bring both together to see how the consumer will maximize their utility. So you can put a subheading or heading for this, bringing the two together. So now we'll bring the indifference curve map as well as the budget. Those are my indifference curves. I think 3 is plenty in an exam because you can have one above and one below the one you're analyzing. And we'll draw a budget line. I would like to go as far away as possible. Agree? Why would I like to go as far away as possible? Because my utility will go up. Is bundle X affordable? How do you know? It's on the budget line. Is bundle Y affordable? Yes, it is also on the budget line. Is bundle Z affordable? Yes, it is also on the budget line. But a consumer not only wants to buy a bundle that's affordable, they want to get the highest level of utility possible. You want to go to the highest indifference curve, which in this case is indifference curve 2. So bundle Y has the highest utility. We call Y the best affordable bundle, or we can call it the utility maximizing bundle. Are there bundles more satisfying than Y? Yeah, there's lots of bundles more satisfying than Y. A is more satisfying than Y. Yeah? Anything above Y on a higher indifference curve is more satisfying. But the problem is, A is not affordable. That's why we say Y is the best affordable. Now if you look at it closely, I'm just trying to see how close this can go. Wow, it's better than Macquarie Theatre. If you look at it closely, wow, it's really good. If you look at it closely, at that point, the blue line, see on this end, I can't even point now. Which one is steeper, orange or blue? Steeper. Orange. Wow, I just moved my pen a little and it flies. Which one is steeper here? Orange or blue? The blue line is steeper than the orange. But here, the two are exactly the same. It's just touching each other, yeah? So at Y, they should get this in Macquarie Theatre. We should move Eco 111 here next semester. So at Y, you have the slope of the budget line and the slope of the indifference curve are just equal at that point. What do we call the slope of the budget line? The relative price, Px over Py. What do we call the slope of an indifference curve? The marginal rate of substitution. At the utility maximizing bundle, the two are equal. You need to know this, which is the utility maximizing rule. Is that okay? Now, using our example, how how much was PX? 10. PY was 5. So what is the marginal rate of substitution at Y? 2. Because the two are actually equal, right? Px over Py is 2, so the MRS at Y must be 2. So at the utility maximizing bundle, the MRS, which is the slope of the indifference curve, must equal the price ratio. Px over Py is the relative price, and the intercepts are, what are the intercepts? Real income. So the intercepts of a budget are the real income, whereas the slope is the relative price. All good? Now, we'll need two graphs, one directly above the other, please. If I'm drawing in different scales, what's the y-axis? That's qx, so the y-axis is qy. In different scales is always two different goods. So let's say that the consumer is maximizing their utility at a certain bundle. We'll call that indifference curve 1, budget line 1, and the consumer is currently maximizing their utility at bundle A. They're buying a certain quantity of X, and they're buying a certain quantity of Y. Let's say that the price of X went down and nothing else changed. The price of Y is unchanged and income is also unchanged. The only event that's occurred is that X is now cheaper than before. Is that okay? So I think we had pizzas were up, what was it? Burgers were $10. Let's say burgers falls in price to, what's an easy number? $12.50. No, that's not falling, that's rising. $7.50. So before your $100 could buy 10 burgers, and before your $100 could buy 20, whatever it was, pizza, slices of pizza. If the price of X falls to $7.50, how many burgers could you buy? 100 divided by 750. Calculators. 100 divided by 751, 1, 30, 30, 750, 14. No? Is it? 13.33. Sorry? 13.33. Oh dear, why did I pick this number? So we can buy 13 1/3 burgers. What if I spend all my money buying Y? That will still stay at 20, right? That wouldn't change. What will happen to my budget? my budget will now rotate outwards. Would you agree? The budget has now rotated outwards. Is A still affordable? Is bundle A still affordable? Yes. How do you know? Because it's still inside the budget line. Bundle A is still affordable because it's still inside the budget line. However, it is no longer the best affordable. So, we say that the consumer will look, if you could add, the consumer will now look for a new utility maximizing bundle. The consumer will now look for a new utility maximizing bundle. So in the exam, don't stress, just poke an indifference curve randomly somewhere, right? We'll all have different indifference curves. So you're just meant to just draw a tangent point somewhere. As long as the indifference curves don't intersect, as long as you just put a tangent point in. So put a tangent point, make sure the indifference curves don't intersect, and you can call that indifference curve 2. We'll call that bundle B. So look at your new bundle and just draw a tangent point on that new bundle. Can you see what's happened to the quantity of X? The quantity of X has actually gone. The quantity of X has gone up. The price of X went down. The price of X went down. The quantity of X went up. This is known as the what? When you see the price and the quantity going in opposite directions. This is the law of demand. The price of X has decreased, the budget rotated outwards, the consumer could afford A, but no longer maximizing utility at A. We look for a new utility maximizing bundle, which is the new tangent point. We look at what happens to the quantity of X. In first year, if the price of X changes, we are not going to ask you about what happens to good Y. Don't worry about what happens to good Y. Okay? That's in second year micro. So when you all do second year microeconomics as your elective, when you all swap your major to economics, hands up if you're swapping your major. Just pretend, just raise your hand just to make me feel happy. Just raise, everybody raise your hand. See? In second year micro, we'll look at what happens to good Y as well. Okay? But for us, as long as you're okay with what happens to good X. Actually, the interesting part is when you analyze what happens to good Y. Because in my one, what happened to good Y? Up or down? Down. Hands up if your diagram said stay the same. We've got some stay the same. Has anybody got good Y increase? Yeah, see, we've all got different answers, right, for good Y. That's the interesting part. But good X is the boring one. So second year micro, yeah, just to find out about good Y. Just come secretly to the lecture at least. Yeah. Some of us have decreased, some of us have stayed the same, some of us have increased. Yeah. Okay, so now that you can see px going down and px going down and qx going up, we can now plot a relationship between px and qx. So we're going to what is called derive a demand for x. What you do is you drag the numbers from the top to the bottom. The price of x went down. We went from P1, which was $10, to P2, which was $7.50. When the price was $10, we bought Q1. We'll call that A dash. When the price fell down to $7.50, we bought bundle B, which is Q2. We'll call that B dash. Yeah. Price is going down. Quantity is going up. What do I have? What is that? You must be not in my class. We don't call it a demand curve. If you say demand curve in the exam, you get 0. What is it? What is it? It's a demand curve. It's not a demand curve. It's a demand curve for good x. It's a demand curve for good x. Interesting, isn't it? Look at that. Emily's here. Where did you come from? Were you there the whole time? Oh, I think you blended in with your shirt and your seat color. It's the same. Yeah. So, when we talked about the law of demand, we said there were two effects behind the law of demand. What were they? There are two effects that explain the law of demand. The substitution effect and the income effect. The substitution effect and the income effect. So the very last thing we did in consumer theory was to break down everything we've just done into the substitution effect and the income effect. To do that, all we need is the top graph, but because that's a bit messy, crowded as it is, we'll draw one afresh. Top graph all over again. And you can put a heading, decomposing into the two effects or destructing into the two effects. The aim is to see the two effects at work. The aim is to see both effects. By both I mean income and substitution. Okay, the rule is this, and you'll just need to know that. Does anyone know the rule? What's the rule? To break it up, we need to do something fancy. You take the new budget back to the old indifference curve. So if you could remember that, take the new budget back to the old indifference curve. So you literally put your ruler there. Everyone do that? We have some people without rulers. They are not really Econ 111 students. You need to have a ruler. Look at the amount of rulers I have. 1, 2, 3, 4, 5. Take your ruler and you move the new budget where? Back to the old indifference curve until you hit a tangent point. You keep moving the new budget back to the old indifference curve until you hit a tangent point. We'll call that bundle Z. Everyone say Z. Everyone say Z. Not Z. Z.
So, wait, the dotted line, what are you trying to get?
Yeah, I'm coming there. So there are two effects, right? On the way from A to B, we bought more X due to two reasons. One is the substitution effect, and one is the income effect. By moving the new budget back to the old indifference curve, I am restoring the consumer's original utility. I'm trying to see what they would have bought had they been able to afford the original utility. That's what bundle Z is about. What they would have bought with the new prices at the original utility. That's what Z is about. Because by changing the price, we change the price ratio, right? So had they been able to afford this original indifference curve, they would have bought Z instead. So we call the movement from A to Z the what effect? We call the movement from A to Z the substitution effect. Because it is due to a change in the slope. And what does the slope represent? What does the slope of an indifference curve represent? Relative price. Slope, oh sorry, I said it the wrong way. What does the slope of a budget represent? The slope of a budget represents the relative price. And if you look back in your notes about the substitution effect, The substitution effect is about the relative price. That's why we call A to Z the substitution effect. If you go back and look at the notes on demand, substitution effect is how the consumer changes their behavior due to a change in relative price. That's the definition of substitution effect. I'm just connecting that definition to the graph. Slope of the budget represents relative price. We've gone from A to Z because the budget has changed in slope. Therefore, A to Z is the substitution effect. Is that okay? Change in the slope means change in the relative price. That's why A to Z is the substitution effect. Z to B. Have we changed the slope? Z to B. It's a parallel shift, isn't it? Parallel shifts are all about changes in income. Parallel shifts are all about changes in income. Therefore, Z to B is the income effect because it is a parallel shift. Is that okay? So we've gone from A, Q1, to B, Q2. Some of the reason from A to B is the substitution effect. Some of the reason from A to B is the income effect. Substitution effect is all about the change in the slope, because changes in slope are about relative price, and that's what the definition of the substitution effect is. Income effect is about changes in income, and that's the definition of the income effect. Amazing, isn't it? Yeah. And it gets more interesting in second year micro. Yeah. There's lots of this.